In this video, we will demo the use of the primer creation tool Twzlr for gene insertion into Vibrio natriegens. This tutorial assumes that all of the necessary dependencies have been installed and the code folder in the repository is the current working directory. To facilitate the walkthrough of the tool usage, we will be constructing the basic combinatorial design shown. The tool will allow us to obtain the primers to construct all possible gene combinations found in our design, in this case, 2 of them. Let's begin. In console, to run the tool, type python twzlr.py and press enter to execute. This will bring up the settings configurations menu, and we will select our desired parameters. The first parameter is selection of which chromosome we wish to edit. We will select number 1. If no chromosome is selected, the code will not run. We then move on to insertion range, or a single insertion point is also acceptable, where we specify the range to cut. For the purpose of this tool, or this run, we will stick with 3000. We then move on to primer homology arm length. For this run, we will set it to 50, the default value. We can then select the polymerase or toggle whether or not we want to use adapters, but we will leave those default for now. We will then click Select Results Output Path, and using this, we will specify exactly where we want the results of the tool to save. For the purpose of this demonstration, we will select the folder where the code is located. Once we are satisfied with our parameters, we will click Save Settings and the main interface will be displayed. Now we will have to convert our rough combinatorial design into an array of data. This tool uses a 2-dimensional format to store data broken into layers, which are indices, and genes, which are subindices. Here, we display a graphic to help visualization of our design into the dimensions required by the tool. This is how we will insert indices and data into the GUI. To pull data from the database that we use, navigate to NCBI, a basic Google search will get you there, and from databases we will select genes. We will search the first gene to be inserted and click on the link to the first entry. We will copy the gene ID and insert it into the first entry line of the interface. We will then return to the NCBI page, and in Insert Base Range, we will have to place the base ranges for the gene in the parent genome. Once we are satisfied that both of these conditions have been met, we should double check the indices of where we are adding to make sure they match up with our combinatorial design and press Add Gene. Notice the updating of the list on the top left corner of the interface. Now we will move on to the next gene in layer 0, and because we are a bit familiar with the process already, we will move a bit more quickly. We select the ID, add it to the GUI, and then for the base range, we will place the base range shown on the NCBI page, double check the indices, and then we will press Add Gene. Now we need to move on to our last gene to be added, but notice that it is in a different layer. To add a different layer, we will go to the layer box, change it to the layer that we will be working with, and press Add Layer. While this doesn't produce a change in the list, it has added the layer. Now we navigate to the GFP entry for NCBI. And again, since we are familiar with this process, we will move a little more quickly, inserting the data specified and or required, and we will hit Add Gene once we are satisfied after double checking the indices. If we were to misclick and add an extra gene to where it should not be, it is simple to remove. We go to the Remove Entry line and we place the index of the gene to be removed from the layer in the entry box above it. Once we are satisfied the data has been entered correctly, we will click Run Tool. This will close the interface window, and we will need to give the tool a few moments to run. Once a graph is displayed, the tool has finished running. This graph will not save automatically, so the user may save it under their own specifications if they would like. This graph specifically describes the possible combinations that come out of the design that was inputted in the main interface. We will then navigate to the original selected output path for the results that was specified in the parameter interface. Opening this directory, we find a new JSON file named Twzlr primers. If we open this file, we will see sets of primers for each possible gene configuration. Each combination is labeled specifically with the locations and genes that it represents. For the case of our design, the tool should have outputted 4 sets of primers, and we may verify that it ran correctly by looking at the JSON file. This concludes our demo of the Twzlr tool.